Hello guys, so in this video I am going to discuss some problems based on model number 2. So first thing we have to remember that in model number 1 server is equal to 1 and buffer size was given as infinite, but in model number 2 server is only 1 and the buffer size is limited to k. So I have taken this example to easily understand model number 2. So problem statement says that trains arrive at the yard every 15 minutes and the service time is 33 minutes. If the line capacity of the yard is limited to 4 trains, find the following things. So here it's clear given that if the line capacity of the yard is limited to 4 trains, so it means that the capacity of system is limited to 4 only. So the generally problem is based on model number 2. Now we have to find out the probability that the yard is empty and the average number of train in the system. So average number of trains in the system, that is length of queue in the system for ls, and length of queue it will be l. So we have to find out ls, and in first one we have to find out that is what is the value of probability that no train will be there, so p naught. Now first thing we have to note that we have to find out here lambda and mu. So as it is given in the question that every 15 minute arrival rate is given, that every 15 minute one train is coming, so lambda will be arrival rate will be 1 by 15, that is trains per minute. Okay, and now service rate, here it is given that 33 minute it will take. Now for one train 33 minutes, that is service time will be 1 by 33 trains per minute, and now capacity is limited to 4 trains, so capacity will be fixed as 4. And now the simple thing is, here we have to find out that traffic intensity will equal to rho is equal to lambda by mu, which will be equal to, we put the respective values lambda and mu, we will get 2.2. Now for first problem statement, we have to find out the probability that yard is empty. So for finding that probability is yard is empty, so we have to use the formula for p naught, as I already discussed in previous video. So p naught is equal to 1 minus rho divided by 1 minus rho to the power n plus 1. So put the respective values of rho and n, we will get 1 minus 2.2 divided by 1 minus 2.2 to the power 4 plus 1. So it will give 1.2 divided by 15.536. And now the probability that no train will be on yard is equal to p naught, and its give value as 0.0237. so this how we are able to solve our problem number 1. And now the problem number 2 states that find the average number of trains in the system. Find the average number of trains in the system. So for that we have to apply the simple formula for ls. Ls is equal to p naught summation from n is equal to 0 to n is equal to 4 and n multiplication with rho to the power n. So as it's adds, the summation is here taken, so on expanding the summation we will get rho naught whole multiplication with as n is proceeding from 0 to 4, so putting the value n is equal to 0, so 0 dot rho to the power 0, then 1 plus rho to the power 1, then 2 plus 2 multiplication with rho to the power 2, and plus 3 dot rho to the power 3 plus 4 dot rho to the power 4. So this is how we can expand this ls formula. And now on putting the respective values of rho naught, rho 1, rho 2, so this is the simple one, we have to put the value for, so this is p naught, so p naught is 0.0237, so put this value, and this is rho is equal to 2.2 as I discussed in previous. So as it is going to multiply with 0, so whole term will be 0. And now in this, multiplied with 1, multiplied with 2.2, then 2 is multiplied with 2.2 to the power 2, and then 3 multiplied with 2 to the power 3, then 4 multiplied with 2 to the power 4. So we have to now find out the simple mathematical terms, and now we have to add these things. And simply, if you put all these values, you will left with this one. So this is only P0 is 0.0237, and this term is 2.2, and this term get 9.68, and this term is 31.944 plus 93.70. and now if you add all these things and multiply with 0.0237, then we will get 3.259. so according to the question, average number of train in the yard in the system we will get as 3.259. so this is a mathematical term, but in day-to-day life almost 3 train will be there in the yard, average number of trains. Okay, and probability that yard is empty, we have calculated this as 0.0237. so means that it will be not be empty all. So this is how we are able to solve model number 2 questions based on Queen theory. So just take a look on it, and please remember that proceeding with model number 2, you have to find out that the capacity of the system will be limited to, okay, and here it is given as 4. so accordingly you have to use the formula for P0 and LS. If it follows some different model, then you have to use different formulas to find those solutions. So thank you very much guys to watching these videos.